Live from the Washington, D.C. area, it's the Inside Scoop, Emerald Planet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the Emerald Planet, Dr. Sam Lee Hancock.
Hello and welcome to the Emerald Planet as we come to you from Washington, D.C. and the United States as we're looking around the globe in 144 different nations, looking for those 1,000 best practices, technologies, services, and products that are making a difference as we go through the 21st century. And we're looking for ways that we're going to be able to improve the climate, at the same time to take care of the soils, the water, and the air as we move to a planet with 9 billion people by 2050. So how are we going to be able to do all that, have this balance, at the same time to increase the quality of life for all the citizens? And we have a gentleman that's joining us. This is Alfredo Quarto, who is the Executive Director of the Mangrove Action Project, coming in by Skype. And sitting right beside me is our special guest who's been on before, no stranger to Emerald Planet, Sudheer, who is the Outreach Specialist, Biodiversity for Livable Climate, DC chapter, and he's, as you can see, in the studio. So, Alfredo, welcome to the Emerald Planet TV.
Thank you for inviting me.
Glad to have you here. Tell us a little bit about your organization, and has a very interesting name. And let us know exactly what it is that you're doing, and a little bit about the mission and the vision.
Okay, in 1992, I was traveling in Thailand doing a story on environmental issues in Thailand, and I ran into a problem of mangrove forest loss in southern Thailand. I was due to shrimp farming, which was expanding very rapidly and causing loss of mangroves. So I was interested in doing something about that by forming a worldwide network that would take on the issue of mangrove loss, but as well inform people of the importance of mangroves worldwide. And the network was very successful in finding other groups that were working in other nations, from Indonesia and Malaysia to India and so on, Ecuador and Honduras. And all these different groups were working for many years to try to preserve the mangroves, and were fighting against basically efforts to destroy them from development pressures. And so we tried to form an organization that would raise awareness about those kinds of problems and help the local people to retain their resources, which the mangroves provide. And Mangrove Action Project is more than a network. We also are doing work restoration-wise.
Okay, tell me it's ready.
Education of the local people.
The work that you're doing is, many people would say, that's very interesting, but what are mangroves? And then what is the benefit of having the mangroves?
Sure. Mangrove forests are very important ecosystems. They're a rainforest, basically. They're a coastal rainforest, and they live along the coast of tropical and subtropical continents, and including in Florida, in the U.S. and so on. Florida, Texas, even the Louisiana area has some mangroves. So we're trying to help raise awareness about the importance of these. They're a tropical rainforest, like I mentioned. They live in brackish water conditions, and they are able to survive saltwater conditions through building up resistance through getting rid of the salt in their leaves, or their root systems can filter out the salt, and they're able to survive basically where other plants cannot survive. They're vital for fisheries, for nurseries for fish and other wildlife, like migratory birds use the mangroves. They're very important for coastal control of erosion and against storms and hurricanes, even tsunamis. They're protecting the coastlines from that kind of force of nature. And so mangroves are very important for the world's future for carbon sequestration as well, in helping to store carbon for almost thousands of years in their peat soils. And they sequester more carbon than any of the tree species. That's why they're very important today.
Well, it's really interesting. We have your logo on here, and that's very telling. Tell us how the mangrove actually starts and then it grows, just looking at the emblem that you have here as far as your logo.
Well, the mangrove will have seedlings that grow on the tree itself, and it's called viviparity, where the actual seeds form roots while still on the tree itself. And so when they fall to the ground, they fall into the tidal waters, into the intertidal zone, and the tides will take them out and then bring them back again, and they plant themselves basically in the substrate beneath the trees where they've landed, basically. Through tidal action, they'll make what they call zonation, where some mangroves will grow lower in the tides, other ones grow higher in the tidal areas. And the mangrove seed will grow in different zones and different seedlings. There's about 72 types of mangrove seeds and plants. And these plants are very important for protecting the coastal areas, like I mentioned. And they buffer against storms and winds and so on, and wave actions, holding the soils in place and thus protecting the coral reef and the seagrass beds.
Alfredo, can you actually see this image that I have up here now?
I do see
Yeah,
it,
go ahead and let's just talk through these, because these images, I think, are really important for both our domestic and international audiences. Of course, many of the internationals are living in these areas, particularly Indonesia, Bangladesh, Sri Lanka, places like that. But let's just go through these, and I'll just click through and just tell us what we're looking at and why what they're doing is so important.
This is an estuary, basically. The mangrove canals or channels of water, rivers often run through the mangroves in very winding paths. You'll see the mangroves growing on both sides of the waterway there. And they provided a lot of habitat for nurseries for fish at low tide, or high tide, I should say. At low tide, they provide habitat for birds, migratory birds, and other animals that live in the mangrove areas. And you can see the protection they form. The waves or winds will hit those trees and be buffered by them to slow down the force of their energy and help protect the areas internally, inside those areas. So they're very important for that. The roots of the mangroves, we talk about the mangroves being the roots of the sea. They're basically an intertidal zone, but they're the interface between land and ocean. In a sense, they live in both worlds at one time. At high tide, they're living in the sea. At low tide, they're living on land. So they breathe the roots, and the root system is very important for not just stabilizing the soil, but also protecting against those kinds of forces of waves and winds. The local people here in this picture you see are fishing near the mangrove. They have these nets they throw, and they can gather the fish and shellfish and so on from the mangrove areas. They're very important for the local communities, for able to get their food and their fishery, basically, their livelihoods from the mangroves. And so local people depend on mangroves. Also, this shows a picture of the Bengal tiger in the Sundarbans. And mangroves are vital for endangered species like the Bengal tiger, which live in the mangrove areas of India and Bangladesh, Sundarbans. They're also very important for other wildlife. I mentioned the migratory birds, for fish, like the lemon shark that lives in the Bahamas and so on. Many species of animal depend on mangrove forest, and the coral reef depends on mangroves.
All right, we're going to leave this one for just a few minutes. So let's go ahead and let Sudheer ask his question, then we'll go directly to this chart then, if you don't mind, Alfredo.
Fine, yeah.
Hi, Alfredo. Great that you could join us. What are the main threats to mangroves today?
Well, I mentioned shrimp farming is one of the main threats. It's expanding along the coastlines of many countries. Other industries like tourism, urban expansion, for one, building roadways without proper culverts can cause loss of mangroves. A lot of expansion along the coastal areas is happening today because the coastal areas are basically valuable for certain industries, such as tourism and so on. So we're seeing that kind of loss still happening. About 1% per year of mangroves are being lost, which is way too much. That means about 150,000 hectares a year are being lost. And this chart you see here in the picture shows that loss over the years.
Yeah, that's a huge loss. Looking at the mangroves themselves, you went over this a little bit, but let's go more in depth, Alfredo, about how the mangroves actually help to possibly stop or reduce the amount of damage that's being done by climate change, and then also these excessive violent storms that we're getting now, which are becoming almost the new normal with climate change.
Sure. Yeah, the mangroves actually sequester more carbon than any of the tree species other than the salt marshes and the seagrasses. Those three plant species are very important for climate change abatement, basically. 5 times more than rainforests, tropical rainforests, the mangroves sequester carbon. And more than that, they store it for hundreds, if not thousands of years in their peat systems. And this is very important. Mangroves are an excellent sink for carbon sequestration. But when they're cleared or destroyed for developments, they become a source of carbon, releasing a lot of the carbon they've stored over the millennia back into the atmosphere again. And this is very detrimental for climate change issues. So we're really endorsing the idea of not only restoring the mangroves back to where they were as much as possible, but also conserving whatever is left, because only half the mangroves still exist. Less than half still exist on the planet Earth. About 15 million hectares remain, possibly less than that now. And we're trying to say to people, please keep your mangroves intact, help restore them in places that are needing restoration, and we can then recover some of the positive benefits of mangrove restoration and conservation through climate change mitigation.
Now, we're working with an organization and also have been on Emerald Planet several different times where they have what they call ancient and giant trees all over the planet. And they're actually now cloning trees that go back 3,000 to 6,000 years, which scientists say you can't do it, but these guys are doing them by, the millions and planting them all over the planet. Looking at the mangroves, do you have that same dynamic with mangroves that you have with the sequoia and the redwoods and others?
Well, they don't live as long as sequoia, for instance. They live to be, sequoia can live 4,000 or more years. Mangroves have a shorter lifespan because they're a tropical forest, and they'll die and other plants will grow up from among the dead plants. But the mangroves do have a long ecosystem existence in places like Thailand and so on. There's evidence that they've been around for millions of years, and a big biodiversity of mangrove exists in those areas. One of the problems we see in trying to restore mangroves today is you're trying to plant one species, usually the Rhizophora or the red mangrove, avoiding the problem of other species planting. This causes loss of biodiversity, which we're trying to discourage and try to encourage more normal or natural restoration techniques.
We're about running out of time here, and okay. You've done an absolutely fantastic job in sharing this about mangroves. What is your organization doing as far as saving the mangroves? And I think this may be a picture of one of those.
Yeah, this is called a community-based ecological mangrove restoration, CBEMR, and we're using that term to define the involvement of local communities in actually restoring the mangrove hydrology by basically opening up the channels again that were running with water that help feed the mangroves the nutrients they need and help the substrate develop the mangrove area so it can come back again naturally. And this will in turn reduce the problems of monocultures and so on. We're trying to get more biodiversity back into the mangrove restoration to restore the ecosystem functions.
Well, I tell you, it's very impressive what you're doing. We're running out of time. One thing, how can people get involved with you? And secondly, what do you see for the growth and expansion of Mangrove Action Project over the next 5, 10, 15 years?
Please come to our website. It's mangroveactionproject.org and check us out there. We have a lot of information there and things you can do. We're asking people to join us, help support us through donations or for volunteer work. We have offices in Thailand, people working in Cayman Islands in the U.S. and around the world, actually, we have projects. So please get involved if you can through our website.
Okay, well, thank you very much. This is Alfredo Quarto, as the Executive Director of Mangrove Action Project. Sudheer is Outreach Specialist for Biodiversity of Livable Climate, sitting right beside me. And thank you for being with us as we look around the globe to create the Emerald Planet.
I need a job.
Necesito trabajo.
I would like to speak English better.
Me gustaría hablar inglés mejor.
I want to be a U.S. citizen.
Quisiera ser ciudadano de los Estados Unidos.
For over 35 years,
Por más de 35 años,
the Hispanic Committee of Virginia has been serving our community.
el Comité Hispano de Virginia ha estado sirviendo a nuestra comunidad.
Job training and placement,
Capacitación, ayuda para conseguir trabajo,
education for children and adults,
educación para niños y adultos,
immigration, naturalization, and medical referrals.
ayuda para los procesos de inmigración y naturalización y orientación sobre médicos
Are a small part of what we do.
son solo una pequeña parte de lo que hacemos.
For help, information, or to volunteer,
Para ayuda, información o para ofrecerse como voluntario,
contact the Hispanic Committee of Virginia,
comuníquese con el Comité Hispano de Virginia,
helping everyone participate more fully in American society.
ayudando a todos a participar plenamente en la sociedad norteamericana.
Hey, Lena, where's yours?
Would you notice if you were missing half your kidney function? According to the National Kidney Foundation, 20 million people have chronic kidney disease, and 20 million more may be at risk and not even know it. Anyone with high blood pressure, diabetes, or family history of chronic kidney disease is at risk. Early diagnosis is vitally important. To get the whole story, talk to your doctor and visit the National Kidney Foundation at kidney.org or call for a free brochure. Because when it comes to chronic kidney disease, you might not know the half.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you on a week-to-week basis looking for those 1,000 best practices, technologies, services, and products that are making a difference as we move through the 21st century. And of course, we're looking for the leadership that is making the difference as we move towards 2050 and a planet which may have as many as 9 billion people. And so looking at that, how we're going to be able to protect the planet, try to reverse climate change, and at the same time provide livelihoods for 2 billion new people that will join the planet. We have someone that's actually working on this very idea and how we're going to be able to balance the environment as well as the economy and also social society development. Martin A. Keeley, who is the Global Education Director for Mangrove Action Project. He's coming in by Skype, and sitting right beside us, our good friend and almost becoming a regular on Emerald Planet TV, our special guest, Sudheer Shukla, who is the Outreach Specialist, Biodiversity for a Livable Climate, DC chapter. And welcome, glad to have you here with us. And Martin, welcome to the Emerald Planet TV. Okay, you're not coming through. Okay, let's get it. Let me say welcome again. Make sure you're coming through.
Okay.
There you are. Got a good voice. All right. Welcome. Thank you, Martin. Tell us a little bit about your organization's, this global education program that you're involved in for the Mangrove Action Project and how that dovetails with the long-term mission and vision of your organization.
Well, Marvelous Mangroves, the concept of it was developed about 30 years ago. And the idea is to give children, particularly at the primary level and perhaps intermediate levels at the high school, an understanding of ecology, of mangrove ecology, how ecosystems work, and what our impact is on them.
Yeah, looking at that, you have something that's called marvelous mangroves. What is a marvelous mangrove? Because I thought they were all marvelous, but I guess some are better than others maybe. And how would you explain its origin and its use now in actually 13 different countries?
Mangroves have a lousy rep, don't they? And that's part of the problem, is that still they're considered nuisances and wastelands. It's a wetlands problem worldwide, no matter whether it's mangroves or freshwater wetlands. The idea is to work in different countries over an extended period of time, working through the education system and through the teaching system to be able to get kids to understand it and get kids down the road to be able to implement that knowledge when they move into positions of power, if you like.
Yeah, now looking at your logo here, I think this is very nicely done, and it really explains what a mangrove is just by the very image. But when you're trying to teach this to children, how they grow and the importance of them, how do they understand what a mangrove really is versus maybe something that's purely an on-land tree that has a very different root system and really has a different life cycle?
Good question, Sam. Well, the whole concept and the whole premise behind Marvelous Mangroves is to teach students through hands-on science and through exploration. There's enough pedagogy to float the planet, and nothing gets anywhere if you don't actually explore it in a physical manner, and a physical manner in a way to understand that how it functions. So obviously the first method you have to use is to understand that most trees die if you dump salt water on them. Mangroves don't. So how come they don't? So then you go through a whole process of exploring that, again through hands-on science, through field trip explorations.
Now looking at this image here, I believe you can see this, Martin. Yep. This is a very complex picture, but it really, I think, explains very well what you're doing in these seminars and on-site demonstrations. Go through this a little bit about what these children are actually seeing, what they're learning, and what they are actually absorbing that they can take back to their own families and also within the communities where they live.
Okay, this is a field trip that we always do at the end of an in-depth, week-long, month-long, however long classroom process where we're actually doing activities in the classroom, experiments, if you like. What the kids are doing here is implementing that knowledge in the field. So they go into the field and they're exploring the different species of mangroves that they're seeing, and they're also with telescopes and binoculars, etc., looking at the different kinds of wildlife that you're going to find there, particularly species of birds, but other kinds of wildlife that you'll find in a mangrove, and they're identifying them. The whole concept is to understand why they're there and to identify their function within a mangrove ecosystem.
Yeah, and they're very complex ecosystems as well, because you have different kinds of insects and reptiles. I mean, it's just, there's everything in a mangrove, there's no doubt, plus lots of mosquitoes. Sudheer?
Martin, so glad you could join us. What is the main purpose behind your program, and how does it differ from conventional educational programs on nature and marine ecosystems?
The problem with most, I hate to say the word problem, but anyway, the problem with most so-called education systems is they're very superficial. You know, you might do a day trip and go explore a beach, or you might do a presentation in a classroom with a whole bunch of slides. But in essence, you're not really teaching anything, you're just touching it on a very, very superficial level. Concept behind Marvelous Mangroves is to get to the whole process in depth. So you're teaching students the function, but you're also teaching the relevance and the importance. And it's the old Confucius saying, you know, I hear and I forget, I see and I remember, I do and I understand. So they are gaining an understanding of how ecosystems function.
Yeah, and looking at that, you can see just how intent and how inquisitive these young students are and the information that's being shared there. But looking at the Marvelous Mangroves, how are you able to introduce it into 13 and in some ways very different types of countries to have it accepted as part of maybe the STEM projects within those countries, but at the same time to really teach about nature and the environment?
We start at the bottom level, which is with either a local institution in that country or an NGO in that country, depending whichever organization you're going to work with, sometimes combining the two or three. And we have a working group of people that adapt. We have the English version has to be translated, first of all, into the language of the local country. Otherwise, what's the point? They're not going to use it. And it also has to be adapted for the specific ecosystems, the mangrove ecosystems in each country, the flora and fauna in each country. Because if it's not, again, it's not relevant to either the teachers or the students or the communities that live there. So you have to work through the school system. Sometimes it works really well. Sometimes it's a bit dodgy, because most developed, I hate the word developing, but most countries where mangroves are found do not have the levels of sophistication that we have in the West. For example, I try to bring in 3-lens microscopes, just basic microscopes, light source microscopes, into each country and into each organization and group of teachers, etc., that I work with, because many of the children and many of the teachers in countries like Suriname, I was just in Suriname, haven't even seen a microscope. We take them for granted. But to understand and see the microscopic world, it opens up the whole planet to these people, especially the students.
Yeah, looking at the images that we have, but talking about some of the obstacles, we've been talking about how you go about the process of introducing this. What are some of the obstacles for this Marvelous Mangroves, which is really needed in these countries, that mangroves in many ways is a lifestay of the culture, of the society, of the environment, but also the local people as far as their economy?
Yeah, exactly. Well, there are some fundamental difficulties. One is that most education systems in many countries are not used to hands-on science. They're not used to this level of hands-on exploration. So you have to overcome that barrier. Once the teachers do overcome that barrier, you can't stop them. And when they take the stuff back to their kids in the classrooms and the schools, you can't stop them. The next difficult thing you have to get through is the bureaucracy, where there's an entrenched education bureaucracy in government, which is used to doing things the way it's always used to doing things. So you have to work with as many of the local education supervisors as possible and work through the system that way. One of the things we do is all the teacher workshops that we do when we introduce Marvelous Mangroves is the representative local education institutions are invited to come and take part in the process themselves so they understand it. So it's not just an imposition on them. They understand it, and then they begin to understand how they can implement it.
Yeah, I think it's very important. Just looking at this image here, I understand that having lived, worked, and traveled in 89 different countries, if you do not have the powers to be involved, then long term nothing's going to happen, because it'll be just a short run, you know, one or one off or two off kind of activity. Sudheer?
Martin, what are some of the impacts you've seen of the Marvelous Mangroves project in the areas where you've introduced it?
Well, there's one I would like to use as an example. We've been looking at the Chinese, one group of Chinese students and teachers here. In a southern part of China, near a city called Zhangjiang, the local shrimp farmers were asked to sell their shrimp farms to the local mangrove organization to turn them back into mangroves. And there were several teachers who were on the local, I guess we'd call them councils, if you like, of the various communities that were voting to do this. And out of 6 communities, 4 of the communities voted to, yes, let's do it, and they've done it. They've reconverted shrimp farms into very successful mangroves ecosystems. The reason they were able to do it was because there were teachers who'd done the workshops and understood the value. They were able to convince the rest of the councils that, okay, let's go for it. So that's the way you can work within. And the same is true in Brazil. That's happened in a couple of locations in Brazil too.
Yeah, well, that's very important. And Martin, thank you for sharing that, because that's a very valuable insight. Well, we run out of time. We have about 10 seconds. Where do you see a very in-depth teaching training program like the Marvelous Mangroves going over the next 5, 10, 15 years? And you got to be quick.
Assuming we get the funding, we've got a lineup of about 25 different countries that want it. So we get the funding, that's going to spread across the
That's planet. Absolutely fantastic. Sudheer, thank you for being with us. Martin, thank you for being with us. Martin Keeley, who is the Global Education Director for Mangroves. And thank you as we create the Emerald Planet.
Osama bin Laden calls getting nuclear weapons a religious duty.
Today, materials that can be used to make nuclear weapons are stored in more than 40 countries.
Sometimes protected by just a chain link fence.
Yet not enough is being done to lock down these materials
before terrorists steal them. Why did we learn all this?
My mother,
my son,
my sister-in-law
were all murdered September 11th.
Help protect America.
Together we can. Please join us.
The stem cell issue is being debated throughout the country. Truth is, most everyone has an opinion, even if they don't know the facts.
Let's stop arguing and start really understanding the potential of stem cell research.
For us and for millions of Americans living with disabilities, get the facts.
Call 1-877-842-3442 for free information from the Stem Cell Research Foundation. That's 1-877-842-3442.
Following the tragic events of September 11th, there have been hundreds of violent attacks against innocent Americans.
Remember what that flag you're waving stands for.
Remember, please stop the hate.
We're stronger when we are united.
Remember what that flag you're waving stands for.
One nation under God.
Indivisible.
With liberty
and justice
for all.
In America, there's either room for everyone, or it's not America. Don't pick the wrong fight.
Let's keep America land of the free.
Stop the hate.
Planning a home renovation? Put this at the top of your to-do list. Because after 10 years, none of you are protected against tetanus and another potentially fatal disease, diphtheria. A minor injury, such as a cut or a scrape, can put you at risk for a tetanus infection. And while safety gear offers some protection, An up-to-date vaccination called the TD booster is the best insurance against tetanus. So get the TD booster. If it's been 10, do it again.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, technologies, services, products, and the people, of course, that are making a difference as we go through the 21st century. And as we grow the planet in population to about 9 billion people, how we're going to be able to provide the food, the fuel, the fiber, the basic infrastructure of education, healthcare, roads, and of course jobs. How are we going to do all this? We have a gentleman who's actively working in many of these areas and looking at what are we going to do to plan for the future of the planet, which will have about 9 billion people by 2050. This is Brian Herzen. He is the Executive Director of the Climate Foundation, coming in by Skype. And then our special guest who's with us and is joining us a number of times now, Sudheer Shukla, who is Outreach Specialist, Biodiversity for Livable Climate, DC chapter. And Brian, you're coming in by Skype, and welcome to Emerald Planet TV.
Greetings. Thank you very much. I'm Brian von Herzen reporting to you from New South Wales, Australia. How are you today?
I'm fantastic. I lived in New South Wales and I love it. And actually I had a text message from New South Wales as I was coming into the studio. So you're in the right place. It's a beautiful area. Tell our domestic and international audiences a little bit about your organization, what it's actually the work that it's doing, but also its mission and its vision.
Thank you. Well, the Climate Foundation over the past decade has focused on food security in soils and in the seas. And the intention is to be able to ensure food security during times of climate disruption, while at the same time measuring the carbon export into our soils with biochar and into the oceans with kelp forests and other biomass.
Now, looking at the biomass, many people think of that as something that's a fuel that's going to be used to be converted into something else. But what you want to do is you want to have the biomass as long as possible out absorbing carbon and sequestering that in the soil. Tell us about that process and why are you going to an all-natural methodology and process in order to be able to do that?
Well, thank you, Sam. I think the essential aspect here is to be able to grow kelp forests as a model ecosystem for how we can actually rebuild the planet. We like to think of the kelp forest as being one of the essential habitats that is imperiled, actually. We've lost hundreds of kilometers of kelp forest off the western coast of Australia and also off the coast of California as well. So we have numerous examples where the climate disruption that we've been seeing has resulted in the decimation of some of these ecosystems. Now we see kelp forests as a great model for potentially regrowing habitat and food for forage fish, base of the food pyramid. So if we can do that, we can actually reboot fisheries on a global scale. This chart that you're showing shows some of the conditions that we've just experienced off of Western Australia. On the left side, you can see the kelp forest north of Perth in 2005, and on the right side, you can see the decimation of that kelp forest that's occurred in 2013. Now, fortunately, off Perth, we still have kelp forest, like is shown on the left, but in a year now, it could turn into the situation on the right. So we need to reverse that kind of decimation of kelp forest that we're seeing, while at the same time really rebuilding our habitats. And we can do that using some of the technologies we've developed recently. And we see that as a great opportunity for food, feed, fertilizer, and biofuels going forward. Ultimately, it's about food security. We need to feed 10 billion people on this planet, and we need to do it without, without water wars and without food riots. And so ultimately it's about feeding people sustainably on this planet, including and improving food security for people around the world that depend on the ocean and on the soils.
I think that's something that's very important, Brian, and you bring it up, and let's emphasize that, this whole thing about food security, and which really leads to local and national welfare and security for all people, because if they can't feed themselves, they don't have the jobs that they need, it is going to have disruption to the society. What is a marine permaculture system, and how does that work into what you're doing as far as the kelp forest?
The Marine Permaculture Array is a recent development that we have worked on over the past 10 years. What it does is it enables us to regrow kelp forests offshore. Now that's a key opportunity, is being able to regrow these kelp forests far from shore, because the kelp forest, of course, creates habitat and food for forage fish. And fundamentally, this is an example of some of the seaweed farmers that we see off of Zanzibar, and also occur in Indonesia, and even also in the Pacific. Over 1,000 square kilometers of kelp is under cultivation, and seaweeds are under cultivation in China. And of course, a lot of that market goes to Japan. So our opportunity is, how do we sustainably grow kelp forests? Well, the problem is, with 93% of global warming going into the oceans today, a lot of the subtropical productivity has shut down. And so the way we bring that back is to restore overturning circulation. We do that with wave energy. Marine permaculture uses wave energy to bring water back up to the surface, and that restored overturning again feeds the kelp. The kelp derives the nitrate and phosphate directly from the seawater and grows forage fish. It creates habitat for these sardines that are shown here, and the kelp is the bright green, lovely trees that create habitat for the fish, and then also food for the fish. I love what Dory said in the recent movie, and that was that, there's blue ocean and there's kelp, but kelp is better when it comes to being a forage fish. So I think she said it all right there.
Looking at this, go ahead, Sudheer.
Brian, so glad you could join us from Australia. Can you say a little bit more about why kelp is so essential to preserving ocean life?
And then also, too, Brian, if you can talk about what is kelp?
Yes, kelp is actually a seaweed. It's a brown seaweed. There are several kinds. There's green, brown, and red seaweed. And the brown seaweed is some of the fastest growing seaweed on the planet today. You can grow over 2 feet of kelp per day off a kelp forest off of California, for example. So it's this wonderful tree that grows faster than almost any other tree on the planet. And it is a foundational species that fundamentally creates habitat and for forage fish, and is the home for maybe up to a quarter of all marine species.
What is the difference between carbon footprints, which you hear all the time, it's in the media, etc., but also you have what's called carbon handprints. So what's the difference between those two?
Well, carbon footprints are the effect we have on our planet when we drive our SUV around or take an airplane somewhere. Carbon handprints are what we can actively do to restore the planet. And in the long term, marine permaculture is one of the essential tools that we have to restore our planet, restore those ecosystems, and restore food security for collapsed fisheries around the world. Now, fundamentally, those handprints can extend to other things. We just met with the Australian federal government, who's funded our marine permaculture program in the Indian Ocean. The U.S. government is now also getting involved on the biofuel side. And here's a picture of the actual coral reef. And it turns out these coral reefs off the Great Barrier Reef, tomorrow we're going to be meeting with the Environment Minister in Brisbane for Queensland, and they've suffered 90% coral bleaching on the northern and central parts of the Great Barrier Reef in the last several months. So what these marine permacultures can do while they're growing kelp is actually cool off the waters. They can cool them off enough to reverse coral bleaching, as you can see on the right. And in 2009, we proved that in our program in American Samoa that was funded by the U.S. Fish and Wildlife Service. We were able to reverse coral bleaching, and it took less than 24 hours. So we are going to meet with the Environment Minister tomorrow in Queensland, and we're going to offer this solution to their reef managers to help them actually reverse the coral bleaching that's existing right now. With business as usual, we're looking at the Great Barrier Reef becoming a geologic relic in the next few decades. And the question is, can governments around the world, including the U.S. and Australian government, step up to the plate and say, this will stop now. This is where it's going to stop. We're going to actually keep these species alive, and we're going to keep these essential habitats going. And that's what the work that we do is all about, is how do we restore those Great Barrier Reefs? How do we actually restore the kelp forest? and how do we ensure enough food security to feed 10 billion people on this planet during this century.
Okay, going through all that, but I want to jump back about 3 steps in all this. You were saying that you're able to reverse this, and we have this image still up on the screen. You're saying you're able to reverse this bleaching in 24 hours?
That's correct.
Tell us about that process and how that fits into this marine permaculture system, because that's an amazing fact, and you're doing this, but it's still amazing.
Oh, thank you very much. The marine permaculture upwells the cool water and actually cools off the surface waters. Those surface waters are essential to the coral reef. What's happening right now on the Great Barrier Reef is that the waters are too warm, and they don't, and fundamentally, the corals are suffering from thermally induced photobleaching. That means the water's too hot, and the corals get unhealthy and they bleach. And so the essential trick is to cool off the water by 0.5 degree and restore the temperature. Once you restore the temperature, the corals come back to life. And so that's how, this is a picture of how the system works. It actually is like a straw dipping down into the deeper water. We use wave energy to bring the water back up to the surface, and it restores that overturning circulation, grows a kelp forest, and ultimately cools off surface waters enough to even reverse coral bleaching. And that's the essential approach, is get the water cool enough so that the corals can come back to color.
Now, looking at this, and we're just about out of time, so we're going to have to close, and let me ask the last question. But looking at this chart we have here, what is the actual cooling that goes on the surface that you can actually do this amazing restoration within 24, 48 hours?
Well, one of my advisors, Dick Feynman at Caltech, said there's plenty of room at the bottom. And in this case, what I apply his statement to is, in fact, there's plenty of cool water at the bottom. And Professor Andrew Thompson at Caltech has confirmed to me that, in fact, there's plenty of, that cool water in the bottom and middle of the ocean is a renewable resource. And there's enough thermal capacity to cool off the surface of the Earth 1,000 times using the middle and deep ocean water, and it gets restored each year. So that's the key, is actually getting that overturning circulation coming back and ensuring food security as well as feed, fertilizer, and biofuels for the planet. So we see that as an essential part of this, and it's all about using that cool water to actually restore the surface temperatures and restore the nutrients that the kelp forests depend on.
Brian, it's absolutely incredible what the work that you're doing. We have about 15 seconds. 15 seconds. What do you see for the growth and expansion of your work as far as the Climate Foundation over the next 5, 10, and 15 years?
In the next couple decades, we expect to be able to feed most of the people on the planet with essential protein that's needed for fish from the sea, and also restoring depleted lands. And so we see those two factors as being essential, and the climatefoundation.org is the place to go for that latest information and see how you can help to actually restore the ecosystem.
And thank you as we look around the globe to create the Emerald Planet.
One day these rats were playing in the woods. One and some matches, and that's no good. Listen to smoke before you give it a try. Only you. Don't play with matches. Don't play with fire. Cause there's nothing very funny about nothing very nice. Homeless mind. So if a gorgeous force is what you desire, don't play with matches. Don't play with fire.
Only you can prevent wildfires.
Fire.
Why don't you just wash your car at home?
When I wash my car, everything runs down the street and down into the storm drains. With all the chemicals in the soaps and waxes, the last thing I want to do is poison my own drinking water. At least here, it's all contained and recycled on site. That's why I also take my car in for oil changes instead of doing it myself. I might take a chance on spilling stuff. You know what the best part is?
What?
More time to kick back and watch the game.
How far would you go to protect the planet?
I want you to build an ark.
Here we go. Okay, that's good. Oh, okay. Ow!
Maybe there's another way.
People, the flood is imminent. Is it too much to ask for a little precipitation?
Go to fightglobalwarming.com to find out what you and your community can do to reduce global warming pollution.
Somewhere around the world, there are men and women of the armed forces risking their lives, helping rebuild communities after natural disasters. collecting toys for needy children, tutoring kids in school. These are your sons and daughters who work to keep us safe, secure, and free. Dedicated men and women who put their country first.
They still need to do the blue ocean thing.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you on a week-to-week basis from Washington, D.C. and the United States as we look around the globe in 144 different nations looking for what we're calling the best of the best, those 1,000 best practices, technology, services, products, and the people, of course, that are making a difference as we go through the 21st century. I'm Dr. Sam Hancock, the President, Executive Director of Emerald Planet and Emerald Planet TV. And we have a gentleman coming on. It's going to be talking about the research that's happening to reverse climate change and to restore the soils, the air, and the water as they were originally, and in ways that's going to have a profound impact not only on the environment but also the economies, and to rebuild social societies within local communities all across the globe in all 214 nations and territories. This is Dr. Mark McMenamin, who is the professor of geology at Mount Holyoke College, and he's coming in by Skype. And then sitting right beside me, our special guest is Sudheer Shukla, who is the outreach specialist, biodiversity for a livable climate, DC chapter. And Mark, I think you're with us already by Skype.
I am, Sam. Pleased to meet you.
Good to meet you and glad to have you here. Tell us a little bit about your duties as a professor of geology at Mount Holyoke College.
Well, as you mentioned, I teach geology at Mount Holyoke College. I have the great pleasure of helping to train some of the best students on the planet, and we've been really making some progress in research and education.
Now, looking at, you have a term that's called Hyper-C, S-E-A. What is that, and why is it important, and how did that come out of the research that you're doing there at the college?
Hyper-C is the concept that all life on land requires interconnectivity in order to thrive. So, for example, vascular plants have to be connected to soil fungi in order for the sugars to pass to the fungi in the soil and for the fungi to secure mineral nutrients and pass them to the plant. And that's what allows us to have a flourishing land biota. It creates all our food. It's really the basis of all human civilization. And the Hyper-C idea I actually developed for one of my classes at Mount Holyoke for the History of Life class, which I just finished teaching this semester. And I wanted to be able to talk to students, explain to them how it was that life made this transition from the sea onto land.
Now, looking at that, and I'm going to have Sudheer chime in just a minute, but looking at this Hyper-C, why did you actually select the name, that name specifically, to describe this whole very complex life that's going on in the soil and the water and the air? And this is a very simple term for something that's extremely complex.
That's a great question. The word Hyper-C is a combination of hyper or beyond and sea or oceans. And so our contention in our 1994 book, Hyper-C, which I wrote with my wife Diana, is that the life forms themselves created an aquatic environment, a Hyper-C that moves onto the dry land of the continents and then allows an incredible expansion in the biosphere. The number of species at least doubles, and the amount of biomatter on the planet goes up by 2 orders of magnitude. That's 100 times.
That is absolutely incredible. Thank you for sharing that with us. I thought that was very important for our viewers. Sudheer?
Hi, Mark. So glad you could join us.
Hi, Sudheer.
Can you explain what a hypertopia is? Why is it important, and how does it relate to Hyper-C?
A hypertopia is a new proposal that I came up with recently to explain what we need to do to deal with proper planetary stewardship and planetary management. And the basic concept is to create new human colonies in generally dryland areas of Earth that, with proper care and maintenance, will grow forests that can absorb a lot of carbon dioxide from the atmosphere. And if we do this right, and if we do this well, it's going to really allow us to expand our civilizations and cultures, but at the same time draw down dangerous atmospheric carbon dioxide.
Now, I tell you, it's really interesting, all these various terms, hyper-sea, hypertopia, and now we're going all the way back to the Ice Age. And I find it really interesting as how in all this research you're doing, the studies and the teaching you're doing at Mount Holyoke, how you're really weaving all of this together. But tell us a little bit about this mini ice age that occurred in North America. When did it happen, and how did it happen?
This is the Little Ice Age that we're talking about, which peaks approximately 1500 AD. And it represents a fairly dramatic cooling that evidently is caused by human activity, or I should say rather the cessation of human activity. This was a time of terrible pandemic plagues. In Europe, the Black Death. In North America, the zoonotic diseases that devastated the American Indian populations. And with this double blow, both in Europe and North America, farms went untended, and the natural vegetation began to grow back. The forests began to grow back. As they did so, they absorbed so much carbon dioxide that they put the Earth into a temporary icehouse situation, which led to the Little Ice Age.
Now, looking at this, I know that as far as your study is concerned, you're looking at this as a bridge into what we may be able to do in the 21st century. So how does this Little Ice Age that occurred at that time directly relate to a planet now that's growing to 9 billion people, and we're continuing to belch out, if I can use that technical term, the hydrocarbons into the atmosphere, and we're constantly warming the planet?
Well, that's a great question, again. And the hypertopia concept is really focused in on something that we learned from the Little Ice Age, and that was that human activities can not only warm global climate, they can also cool global climate by allowing vegetation to return. So the hypertopia concept is this idea that we put people to work. We get young people in newly founded communities in areas that are appropriate for developing a small patch of forest that they can then expand. This can absorb a lot of carbon dioxide, and if we do this right, and if we do this in an appropriate scale, we can actually induce ice age conditions at lower sea level at the same time that we are expanding human communities and contributing to the economy.
And also, too, that would really be the epitome of green jobs. Go ahead.
Hi, Mark. Indeed, it would.
Mark, so towards establishing these carbon sequestering hypertopias, why do you feel a purely secular approach is not going to work?
Well, the secular mode, which is quite appropriate in the sciences when we're studying natural sciences and making the assumption about naturalistic causes and so forth, that's very good for how we conduct science. However, it's not the full story of reality and creation. And if we want to create hypertopias, if we want to create what Pope Emeritus Benedict called oases of creation, we're also going to have to deal with the spiritual factors here as well. So it's not just natural science and politics. It's also going to involve a spiritual element where people are participating in their faith communities, building churches, as well as quail guzzlers to collect the water. So it has to be a full spectrum approach if it's going to succeed.
Now, some people are saying this is really only a quote-unquote technical issue. But what you're saying is, and I think most people in their heart of hearts believe this as well. It's way beyond just a technical issue. And you talked about the spiritual aspects of it, but also it's the emotional attachment. And if you talk with any Native Americans or any indigenous peoples, they have a real emotional connection to the very land where they were born, raised, and in most cases living today. How do we balance that so we have this mind, body, spirit balance going on, and how do we allow people to inculcate that into their own lives so that they understand that it's not just a technical issue, but also we have to look at the spirit and the mind as being part of this whole process?
Well, that was very well put, that Native American traditions have this sort of inherent understanding. We have E.O. Wilson, a Harvard professor, talking about biophilia, this connection that we have with the natural world. And I would say that we need to expand our understanding of this even further and take some knowledge from the Russian world and Pyotr Kropotkin, who spoke of mutual aid. And in his travels in Siberia, he noticed that the only place where the forests were surviving were the places where the organisms were helping one another. They were creating a soil and retaining moisture and allowing lichens to flourish along with the vascular plants and the animals. And so he realized that we're all in this together, that mutual aid happens, and it has to happen in order for a hyper-C to develop.
I think this is really very interesting, also curious. I have a friend who's working with the giant and champion trees, and this is something in the research that they're doing to find out that trees can communicate as long as it's a continuous forest for a dozen, hundreds, even 1,000 miles. The root structures, and they actually seem to have their own language. So we're really getting far afield from the conversation right now. But I think what we need to do, Mark, is come back and revisit this, because I like this theme. And we're realizing that it's much more complex than what we like to think it is.
Indeed it is, and I don't think you were getting as far afield as you thought. This ability for plants and fungi to communicate over hundreds of miles through the soil, I think, is something that's real. It's very poorly understood from our present state of science. And one of the benefits or byproducts of the development of hypertopias is that they would also become laboratories for studying hyper-C.
Oh, that's absolutely fantastic. Well, we've absolutely run out of time. We have about 10 seconds. What do you see for growth and development of your special research?
Well, I'm very much looking forward to developing this further, and particularly I have some very enthusiastic students who want to get going on this right away, and it would be great to be able to send them out and employ them immediately after graduation.
That's absolutely fantastic, and thank you for being with us. This is absolutely a wonderful conversation, and this is Dr. Mark McMenamin, who is the professor of geology at Mount Holyoke College. And Sudheer is sitting right beside me as we look around the globe to create the Emerald Planet.